Welcome back to the next episode. So I've decided to start trying to approach the TDD a bit different. I've got a couple different ideas of how I want to approach it in the filming of it and how I edit things together and whatnot. This episode, I'm going to try just going through and writing all the tests before the episode even starts, and then I just explain them all to you in the beginning. I'm also thinking about going where I explain each test as I'm working on the stuff to do with that test. So, for example, I would disable all the other tests, and then I would just work on this test and tell you what I'm doing in relation to that, and then work on this next test, and then so on and so forth. Let me know down in the comments if you have an opinion on which way I should do that and how I should go about doing it. Or if you like seeing my thought process sort of speak as I'm actually writing the tests. Basically, just let me know down in the doobly-doo what you think. At any rate, for this episode, we're just going to go through and explain all of them. So the tests for here, we're basically going and dealing with equivalency and lack thereof. So these tests have to do with making the entity handle equal another entity handle that is in phase with it. So when the two are in phase, then we want to be able to just say equals equals the other one. So even though they're different objects and normally they wouldn't equal each other, because of the behavior that we're going to be doing, we want them to, right? So this first one here is just simply saying, hey, I'm setting up an entity and I'm making the handle equal the entity. So I'm like making a handle for the entity, right? And then I'm saying, does this handle equal the entity itself? Now, we might want to make this evaluate to true at some point in the future. I'm not sure. I've kind of gone back and forth on it both ways. Let me know down in the comments what you think. But right now, what we're going to do is we're going to say, no, it doesn't. So we can't just say, handle equals entity and then have that be true in like an if. Like, if is handle, right? So that would say, if the handle is that entity, instead of having to go here and say handle.entity equals that entity. I think having that extra little step, it's not that big of a deal. Abstracting that away isn't really necessary, so I'm not going to worry about it. Now, here, we just do that. Then the other thing that we need to do is, if we're just going and making it equal some random object, I also don't want it to return true. So we're asserting that both of those return false. Okay, moving forward, we have another one simply saying, hey, if we compare a handle to null, we want it to be false, right? Simple, same setup as we had before. This one's set up is slightly different because we set up an entity and then we phase it up and then we grab two handles to it so that it has a phase of 1, right? So when we grab those two handles to it, we're asserting that those handles are not the same for some weird reason. They should never be the same since we're calling new on both of them, but why not be a little bit verbose, right? We can afford it here. Then we go and we say handle 1 equals handle 2. Which should return true, right? Because they're in phase, they're both set up to the same entity. So we move forward. The other thing we're doing here is we're testing the behavior of when a handle does not equal the same object. So see, we set up two objects, then we phase them both up so they're in the same phase, but they're different entities, right? Then we set up two handles, one to each of the entities. Now we don't want that to return true when we're comparing the two of them in an equals because, well, obviously they shouldn't equal each other, right? Because they're not the same entity, even though they are in phase with each other. Now let's see, here we're doing a very similar thing, except we're, instead of testing that they're different entities that are the handle's source, right? We're saying each entity handle is out of phase with each other. So we set up an entity handle at phase 0, right? Then we phase it up, and then we phase up the entity, not the handle. We phase up the entity. Then we say handle 2 is equal to the current phase, right? Because we set up a new handle with that current phase. Then we just, again, verify they're not the same. And we set up is false, handle equals handle. Because we don't want that to equal each other because they're out of phase, right? So the next thing we do is we do basically the same thing, except we're using the equals equals modifier instead of the actual methods to equal each other, right? So we go in here, same thing, setup equals. Here, it's a little bit different because up above, we only needed to compare null once because we can never do a null dot equals, right? I mean, technically you could do null dot equals, but we're not overriding null dot equals. So what we're doing is we're overriding our objects dot equals as the method. But when we go and we override equals equals, we do have to try it on either side because there's A and B component, and if either one of them is a handle and then the other one is null, then it will behave differently. So we have to test both cases. You'll see later on in this video that I didn't actually start with this, and I realized partway through that I wasn't doing this because I'm actually recording this afterwards because I decided to do this differently after when I was editing. So you'll see here we just test, hey, does it equal null in a situation where it does equal null because the handle is a null handle, right? So we're saying equals equals null, and it should be true, obviously, and then we're just flipping it for the other one. Then we're trying it again, but this time we've actually instantiated handle to equal something, so it is an instance of something. And so we're just saying equals equals null again, but this time we expect false because it is no longer null. Then otherwise we're basically doing the exact same thing, but using the equals equals on all of this. And it's really pretty much the same. Then we go down here and we're now doing the not equals because equals equals and not equals are different operators. So they can behave entirely different. I could have not equals actually do something entirely different than equal. It's probably a bad idea to do that because I don't know where would use the not equals in various low-level things, but it's something we could, in theory, do if we had a reason to. Now, that's why we go and we actually test for the other situation. Instead of just saying, hey, we have equals equals, so we just say equals 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 false. But that's not how to do it because it's not efficient. We want to have the proper efficiency here. It would save code, yes, but it wouldn't save cycles on the CPU later down the road, which is our main goal here. Now, again, we're doing the same thing, checking the null for both sides with the not equals, but this time you'll notice we're doing false and then true instead of true and then false because, well, it's not equals, right? Same thing here. We're just flipping all the cases so that they're checking for false instead of true and true instead of false. And that's really all that we have in the way of tests for this episode. All right, let's have some fun coding this. Go over to our handle and actually start implementing those, right? So the first one we're going to implement is the simple equals. So we're going to say public override bool. Oops, I can just go override equals. Nice. Now we're going to say compare the values. Then we're going to say return this dot phase equals equals h dot phase. Oops, I never set h, did I? So we're doing an object equals. So here we're going to say handle h equals object as handle. All right, so we're saying yes. We're going to take that object. We're assuming it's a handle, and then we're going to phase. So we're checking the phase, and we're saying yes, the phase is in phase. So we have in phase, right? Then we're going to say this dot entity equals, actually let's compare the internal reference. Internal reference equals the handle entity. So the returned entity from there. Can we actually compare them directly? Oh, I mean, I guess we are in that code, so it makes sense that we could compare them internally when we are inside of that object. Interesting, so that's how protected works. If it was private, we probably would not be able to access them across from the other objects, but since it's only protected, that means since we are writing code inside of that object, it can still access the private variables from the other ones. Interesting, I did not know that that was a thing. So if you pass one in to another one, you could access the internal private variables. That is cool. Okay, anyways, and then we also want to check to make sure that, let's say the object was null. We wouldn't want this to happen, right? So we're going to say here, if obj equals null. If it equals null, then return false. Null should never match a set object. There we go. So now let's run our tests and see what happens. Okay, we've got more errors because remember how I said we were gonna run into stuff where we were gonna mess things up? So this one here is saying it's got a null reference here. So over here, it's saying equals. So when we are comparing it to an object that is set up but is not null, we are getting this exception. Object reference not set to an instance of an object. So what that's saying is that we are handing it, ostensibly what it's saying is that we're not checking this here. So we're just going and saying, hey, make this object a handle. But then when we actually go and, we run this equals, h is not actually set to anything because it failed to set object as a handle, right? So what we're going to do is before we even go and check that, what we're going to do is we're going to say if object.getType not equals our get type, so we don't have to use like type of, return false. So now we just automatically return false if the two types don't match. What? Oh, oops. I did not call it out as a method. There we go. So this is saying if our type here does not match the object's type, then of course it doesn't match, right? Now, we could also do this instead of doing a get type. We could say type of, and then we would say handle, right? So say type of handle, does the other one match that type? We don't need to do that because we're in here and we're only going to be checking against this type. If we were going to be checking handles against entities as well, then we would go and we would do doesn't equal that. We would do like, okay, let's grab this. We'd say that, and so it'd say if it doesn't equal our type and it doesn't equal entity. So in case you're doing it so that it can match an entity, this is how you would do that. You'd say, if it's not our type and it's not the other type we want to match it to, this could be anything as well. It could be like a different kind of handle maybe that we want to be able to match it to. Then return false. Also, this will work with extended objects too, I believe. I think the get type will work with a object that extends this. So another object that extends this type of object will equate here, I think. I'm not 100%. So you'll have to test it. Make yourself some tests to make sure that it behaves the way you expect it to. So now we've got that. Should hopefully clear up this test. Okay, so that one cleared up. So now we can run all of them. And the reason I only ran that one is just to make it a little bit quicker, so that if we didn't fix what we thought we fixed, then it would be covered there. So now what are we missing here? So we are missing this. It says it expected true, but it got false. Now we need to go and override the operation. So this is a fun one. We go and we go public static bool operator, and we're going to override the equals operator. We can override other operators as well. So what we're going to do is we're going to say handle. So we're going to say our A and B. So it's like the right and left, right? So our A is a handle and our B is a handle. So we're saying we're overriding the equals case for when we are calling A equals B. So we're calling a handle equals another handle. Then we are going to be overriding that operator. In here, we are going to say return A phase equals B phase. And then A entity equals B entity. that should be it. What is it complaining about? Oh, right, of course. So it requires, whenever we override equals, we also have to override not equals, because each of them have their own dedicated code, and you should not just call equals as and then flip it. So you shouldn't just go something like this. You should not, I repeat, should not do this. That is bad. Don't do that. Actually run your code in each one, because you want it to be as performant as possible. So you want to actually run the equivalency in there. So you don't want to call out to something else that's going to be running the equivalency. So we're going to say that is not equal that, and that is not equal that. That is okay. We can do that. Or we can even, if you wanted to, you could still say equals and then put those in falses, but that's more than we need to do. So we say A not equals that, and B, oh, sorry, we don't want that. We want to say or, because if either one of these is false, we want it to return false, right? So, or we actually want it to return true because they are not. So if A does not, or the phase of A does not equal the phase of B, then we return true because we are asking for not true, not equal. Or if A entity is not the same entity as B entity, then we also return true because we want the not true. We want the not equals. Yes, that's right. Yeah, because this one we want both to be true, and this one we want either one to be true. Okay, so let's run our tests again. Now you'll notice we've got different things that didn't equate here because we had other methods here just a second ago. Or sorry, other tests that failed just a second ago. So we're going to be kind of cycling through this. I know this feels like we're just kind of hammering nails and another nail comes out when we do it. But this is why you write tests, because this accounts for all the edge cases that we might not if we were just writing this code straight. You know, we might go, oh, those are perfectly fine the way they are, right? But we've got some kind of a problem here. What's the problem? So we're saying here equals null. So we're actually going and running that, and we're running into a null exception because we're trying to get a property of null. Because if A is an object and B is null, then we're going to be failing that out, right? So what we're going to do here is we're going to say, oh, I just thought of something we don't test. Well, I'll show you the problem with the test first. So if we went here and we did the simplest fix, right? We could go if B equals null, then return, and this is going to make a different test fail. Actually, I think this is going to make this fail for a different reason. Return false. So this is actually going to fail via infinite loop, which is a different failure reason than the one I'm going to be showing you in a moment. So this is going to fail, it's going to run for a bit and then fail. Okay, well, it should be telling us that it's getting an infinite loop here. But see what's happening is we're using the equals to check if it equals null. So whenever it equals null, it's going to come in here, it's going to say, hey, or actually whenever we check anything, it's going to come in here and it's say, hey, does it equal null? And then it's going to say, hey, does it equal null? Hey, does it equal null? Hey, does it equal null? Infinitely, because this equals here is this entire function, right? So we're just doing an infinity nested call. So what we really need to do is we need to check its reference. So we're going to check the reference of B against null. So how we do that is we say reference equals null as object A. Well, I mean, you can object A or B, whatever. But and then object B, we're going to say is B. And that's a method call. And then so that's going to actually check the reference itself instead of actually doing a comparison. So we're not looking at comparisons here. We're looking at the reference. Now that will equal false, and we can run this method. And then it should pass, I think, if I remember correctly. Nope, it still fails. Why does it still fail? That equals true. Yes, because it's true. See? The tests caught me messing up on camera. So that's why we write tests. So this should not equal false necessarily, because we want to say if both of them equal, let's see, let's just say if A is null and B is null, then return true. Because if we're comparing something that's supposed to be a handle that is currently null and something that is null, then we're going to be using this because of type stuff that C++ does. It's kind of complicated to explain it. But point is, it's going to be calling this for comparing a null reference to null. Otherwise, it would be calling null, it would be calling equals equals null null, which is, yeah. Anyways, point is, don't worry about it. It's going to be calling this, so we are checking null A against null B. If they are both true, then we're going to return true. You might already be seeing what the problem is with this, but otherwise we're going to be checking against B. So we're going to say, is B null? So we're satisfying the case of the current test, not the case of what the test should be. So we're going to run that again, and what do we have now? Expected false got true. What did I do now? Okay, so equals equals false is, why is that equating to what? Okay, so equals equals null is for some reason returning true. H equals handle. H should be set, so H should not equal null. What are we doing that's making that return true? Oops. See, return true was false. So false. There we go. Okay, so now it went green, but it should not have. See, what we're doing here, well, I mean, it should, because that's what our test is right now, but our test should be different. What we should be testing for is a secondary case of null equals equals H. So what we're going to see here is that null equals equals H is going to behave differently than H equals equals null, because it is a different function call. Right? So we return, we run it again, and this is actually going to fail. And the reason it fails is because these are switched. So if we look in handle, we'll notice now null is not in B, null is in A, because remember I said left and right. So really we could be calling this left and right. But anyways, we can see that it is this is the left one and this is the right one, right? So in here, we're saying if left and right are null, but here we're only saying if right is null, right? So what we really should be doing here is we should be checking both of them. So we say if A is null, and then what do we want to do here? We want to say or, right? So we say if A is null, or B is null, then we want to return false, because we've already checked if both of them are null. If both of them are null, then we return true, because they are the same. But if one of them is null and the other is not, then we return false, because it's no matter what false, right? Because null is null, and null is never something, right? So now that should make this go true again, or should go green again. There we go. And now what we need to do is we need to reflect this in the other null tests, because I messed those up. And that's, you know, that's one of the reasons why I say never implicitly trust your tests. Your tests might be wrong, but make sure that your test is wrong if you're changing your test. You don't want to change your test to work with the object you currently have. You want to figure out why the test is wrong. If it's the test that's wrong, you want to be sure that you know why it's wrong. Because if you can't explain why the test is wrong, then it's probably your object that's wrong, or you just need to learn more about what you're doing. But you should always be able to explain why your test is wrong. What I was doing there earlier when I was, you know, going through and reading each one of the tests and kind of running the program in my head, so to speak, and running it out loud, was what's called rubber ducking. And that's essentially, you know, you're explaining it to a rubber duck, or a wall, or a little stuffed animal on your desk, or another person. You know, they don't even necessarily need to know programming. It's just talking it out and speaking it out loud and running through it. You can see errors that you made. Okay, so now that we've got this being tested for both sides, A and B, on here, let's go ahead and try the not equals. Now, we can see here, we need to do basically the same thing. So we're going to go ahead and we're going to do this in here. So now, though, what we do need to do is we need to switch some of this. So if both of them are null, then they do equal each other. So we need to return false, because we're checking for inequality, not equality. Then we check reference equals null, reference equals null. So if either one of those are true, then we'd return true, right? Yeah, because null is never equal to something. We should be good if we run that test. There we go. That should be good. So now we run the selected test again, and all of them succeeded. Now I could have sworn that I needed to do something else. Okay, that's fine because it checks that. And we could check this a little bit more directly though. Instead of actually calling out to here, we could squeeze a tiny bit more performance by actually directly checking the reference to null instead. We're going to go ahead and check the reference to null here. So if the reference of the object equals null, then we're going to return false. And then one other thing, and this is more of a performance thing than a test thing, but let's just copy this, and then if this is the object. So if the reference to this and the reference to the object are the same thing, so if we're comparing it to itself, it will always just return true without even bothering checking anything. It just says, yeah, it's true, because duh. Because something is always equal to itself. There we go. And because wrong. There we go. Oops, always. Alleys. I don't want alleys. I want always. I'll just spell it right myself. There we go. Okay. I think that's good. So we've got all those tests passed. There we go. Let's run everything to make sure that we didn't break anything over an entity. Okay, we're good. We did it.